Necroxix, and I'm here to over-engineer solutions to problems nobody has. So the rough idea is I want to set up some VLANs, or well, I already have VLANs set up, although I'm not actively using them, and I want to set up another one. Not really a tutorial, but there might be a lot of good reference material here as I go through the steps that I take that may actually prove useful either to myself in the future or to others watching. So I don't want to go too much into what VLANs are and how they work completely, but let's say we have this diagram here representing my current setup that is 1, 2, 3 computers. So right now this is just representing my physical computer that I'm sitting at. And then I have a separate computer on the network, in this case running as a virtual machine, but it could be another physical computer as well as a third. So I'm calling it desktop VM1, VM2, but it could be desktop 1, 2, and 3. Doesn't really matter. Now let's say I was living with 2 other people, so there's 3 of us total, and we're running cables into each room of the house, and we want to separate the bedrooms into separate networks. So that, for example, if I'm this desktop computer here, I don't want my computers to communicate with my other roommates. I only want my computers to talk with each other. And no one else can see that, and I can't see them. And if I wanted to see them specifically in any which way, we can actually configure that. So let's say, for example, I, as roommate number 1, want full privacy. I have a bunch of computers and they're sharing Windows directories and stuff with each other, and I don't want anybody else on the network besides my room to see that. And I don't need to see these 2 at all. Like, you're on the network, you get internet, but as far as you know, my computers don't exist. From your own computer, that is. Now let's say roommate 2 and roommate number 3 want to talk, like they want to connect to the network, and they just want to be able to communicate with each other. Like maybe they're sharing files with their Windows shares or something along those lines. They don't care. Well, you'd probably just put them on the same VLAN. But for this example, we're just going to assume everybody gets put into a VLAN or something along those lines. So I'm going to set up a VLAN that's going to be called VLAN 10. That'll just represent like the home. I'm thinking along the lines of creating a VLAN that's going to be specifically for home users in our network. So I got myself and 2 others being represented as different computers in the network. Only one is physical, the rest are just, we're going to simulate them with virtual machines. And the reason for putting us on VLAN 10 is to be able to isolate traffic from each other, or rather, to isolate traffic from our computers and other services. So for example, you would typically use VLANs for things like Internet of Things, IoT, or security cameras, where you don't really need that stuff communicating with anything on your network. They just need internet access, or maybe they just need access to your storage, and that's it. So you would isolate them, and if there was a backdoor on the device, going out to China and doing who knows what, you have ways of protecting yourself and making things a little more secure. Another idea with VLANs is that if, let's say, my computer is an isolated VLAN and I'm doing something I probably shouldn't be doing, and my system gets compromised, if my system is isolated from the rest, even though we're still on the same physical network, we're isolated. And if it's, let's say, some kind of a worm exploit that can actually infect other computers over the network, if they have the same vulnerabilities, well, it's not going to really get very far because it doesn't see the other guys. So it's another security measure. So now in this example, we have a modem. This is where the internet comes from. It's going into a pfsense router, which I now have set up on a physical server. It is the Dell R210-2. It has one E3 1245V2 CPU, so that's 8 total cores, or at least 8 threads, and I put a Intel 4-port NIC into it. I'm not using the two Broadcom Ethernet ports on the server. I'm using just the Intel, so as far as I can tell, it'll work just fine with hardware offloading and all that kind of fun stuff. So the pfSense router, in my case, of those 4 ports, 1 is going into the modem. 2 of them are actually going into my switch, my physical switch. A third one I'm going to be connecting specifically for this new VLAN 10 for home network. Now, in addition to the switch, because I'm using virtual machines, I have to work with the switches on the hypervisors. So there's I'm doing 2 different servers, 2 different virtual machines in each one. And for every ESXi hypervisor, there's a virtual managed switch as well. In order to do VLANing, you need managed switches. So technically, in this example, I'll end up having to work with 3 separate switches. One a physical, and the other is the virtual one. That'll allow everything to be able to access these VLANs after we configure it. First thing we need to do, I would say, is get into the switches and configure a new VLAN port. Kind of 2 types of ports that you might configure on a managed switch. For this purpose, I'm just going to call it an access port and a trunk port. There tends to be a few different terminologies. So when your desktop is physically connected into a switch, a managed switch specifically, if we want to put it on a VLAN, we would configure an access port. So anything connecting into that is going to go directly onto the VLAN that is configured to go. The desktop computer has no idea whether it's on a VLAN or anything else. It's just dumb to the process. That's all done on the switch. Now, for one switch to communicate to another switch and keep the VLANing, it needs a trunk port. So we're going to take the ports that connect these switches together and add additional VLANs into that port so that it can send traffic tagged with those VLANs. So these are VLAN aware through that trunking port, and then we have an access port that communicates to the virtual machines themselves in this case. Connecting a switch to a device or a dumb switch, it would be an access port, basically. This is a configuration that is known as router on a stick, meaning if VM1 and VM2 are on 2 different VLANs, then they can't see each other unless the switch itself has layer 3 capabilities, meaning it can route traffic, or if it can go into a router which does layer 3, and this will allow you to route traffic between the VLANs. In other words, doing it on the firewall. There's a few catches with doing the router on a stick method, which is one of the reasons why I'm using the extra cables on the interface. So, for our example, for VM1 to communicate to VM2 that's on different VLANs from each other, the packet will go into the switch, and then it's going to go into the router, and then the router is going to say whether or not the firewall is going to allow that communication to happen, pass it back to the switch, and then send it back to the VM2, and then they can communicate. If you take the router out of the picture, these 2 VMs don't see each other. First step I'm going to do is configure the switches. So this is the edgeswitch 24 Lite. I love this switch. Version 1.8.1 point whatever firmware. And I'm using the newer interface. There's a legacy if you need to get like some of the in-depth stuff. But for these purposes, it's fantastic. And we're going to go to VLANs. Now, I already have a few different VLANs for a few different purposes. I'm going to click over here, new VLAN ID. We're going to make a VLAN 10. So VLAN 10 is going to be my home network VLAN. And we have 3 different options here. There's untagged, tagged, and exclude. So for our purposes, we are going to be using tagged. So I'm going to go ahead and tag this on this port right here. I'm going to be physically connecting this cable once we've gotten far enough in the configuration. I have VLAN tags on this port over here, port 21. So right now I'm using 2 cables between the router and the switch. They're trunks. And one's routing only LAN traffic, and then I dumped all the other VLANs onto another port. And I'm going to do the home network computer on yet another port. So it'll be a 3rd physical cable to plug in, and it's going to be right here on port 19. I'm going to hit apply. VLAN settings have been updated. So we have satisfied the conditions for one switch. Now I'm going to need to add some switching. I'm going to have to add some VLAN 10 information into these 2 switches here for my virtual switches. So for that, I'm going to open up my vCenter, my first server. I'm going to click configure and then virtual switches. So I have a distributed switch that I'm slowly trying to phase out and go back to the standard vSwitch. It just seems a little simpler. I don't have any other reason. These all connect to wherever they're going. But for the vSwitches, they have port groups. So this is basically the equivalent of the access port. So the vSwitch is already pre-configured to be trunking out all VLAN ports to my physical switch. So I've done that long ago, or it might have been done by default. I cannot remember. But I need to configure an access port to the actual virtual machines. And to do that, I'm going to add another port group. So I'm going to click Add Networking, Virtual Machine Port Group for a standard switch. I'm going to hit Next, Next, and I'm going to call it VLAN 10, and it's going to ask for the VLAN ID, and we're just going to type in 10. I'm going to hit Next, Finish, and we have VLAN 10 on the first switch. I'm going to do the same thing on my standard switch for the second machine, for the second server, that is. So what we've configured so far is there's a trunking port that'll allow me to connect another cable on the final network interface port of the router into the switch that'll trunk only VLAN 10, and the vSwitch will have an access port available, those port groups. So it's the equivalent of taking your computer and physically plugging it into a switch that's configured to access that VLAN and not a different one. And now comes the fun part of trying to remember how I do this, because I've already done it a few times in the past and it's been a little while. So we want to create a VLAN 10. So I'm going to go into Interfaces in pfSense and click on Assignments. And you can see I've already got a lot of stuff going on here. And I'm going to click on VLAN. I can see I have VLAN 20, 30, and 40, which all do what they do. I'm going to add onto, I believe, so I have port 0 is what's connecting to the modem. Port 1 is connecting to the LAN. Port 2, or EM2, is going into all those other VLANs. And this is the final one that's unused. And we also have the 2 ports that are available on the server that I'm not using right now because they're Broadcom network interface cards, and I just wanted to use the Intel one. So we're going to dedicate EM3 for this, and I'll give it a VLAN tag of 10. I'm going to ignore priority, and I'm just going to call it VLAN 10 and hit save. I could see it's added here, the interface EM3. And if I go to the interface assignments, I should be able to click in here to add it. You can see that there's EM1 on LAN, EM0 on WAN. The VLAN 20, 30, and 40 are all on EM2. So it's like a trunk port for all three of those. I'm going to add VLAN 10 on this drop down here for EM3. Yep. Interface has been added, and I'm going to click on it. Right now, it gave it a name of OPT7. I'm going to call it something else. So first we need to make sure we enable it, and then give it a name. So I'm going to call it VLAN 10 home. I need to give it a IPv4 configuration. So I'm going to give it a static IP. I'm not using IPv6 for this. And we're going to give it 192.168.10.1. So it's kind of like having another router, which is typically, you would see it as like .1.1 or .0.1. In my case, we're using the VLAN gateway as 10.1. And it's going to be a /24. And I think that's all we need. So I'm going to hit save. Changes of configuration has been changed. Got to apply. Don't forget to adjust the DHCP server range if needed. That's important because what this means is if this computer is connected to VLAN 10 coming in, the IP address it's going to request needs to be on VLAN 10, and pfsense is going to provide that for us. So we have to make sure to configure that range. Now we're going to go straight into our DHCP server over here. And you can see that there are extra tabs here. There's VLAN 10 home. And actually, I'm going to rename that so it's consistent with my other ones. So I renamed it. So now it's VLAN 10 home. I don't know if we can shuffle these in terms of order, like it's sorted by alphabet or something. But I'm going to go ahead and enable DHCP server on VLAN 10 home interface. I'm going to not worry about the rest. I'm going to give it a range of 192.168.10.50 to 192.168.10.250. That'll give it 200 IP addresses it can give out to other computers on this VLAN. I'm also going to give it a DNS server of 192.168.1.1, which is a DNS server I'm running on pfsense, so I don't need to use like Google's DNS or something. I already have it running. And the rest, I think I'm going to keep defaults and hit save. Got the interfaces configured. I have the DHCP for this VLAN configured now. If a computer was to connect into it, it would automatically get an IP address on the local network. I'm going to take this cable and plug in that final port into the switch that we configured, and I'll be back. So I've got the cable plugged in now, and I'm hoping I didn't forget a step, because otherwise I'm going to look like an idiot. So going back into our vSphere, I'm going to take the two computers that we have down here as virtual machines, and I'm going to go ahead and connect one of them, let's say this one, into the VLAN 10 network. So right now, this VLAN computer 1, if I was to open a command prompt, if I type in ipconfig, right now it is getting a local IP address on the default LAN. So let's call it VLAN 1. That's the default VLAN. That's the main network. That's not going through VLANs. It has an IP address. If I was to ping google.com, it responds. If I was to ping, let's say, my desktop computer, it can also see it because it's on the exact same network. So now we're going to change that. And I'm going to do that by finding my computer. That's this guy. I'm going to edit settings. And this is the equivalent of switching what port your computer's connecting into on a switch. It's just being done on a virtual switch. So instead of the regular virtual machine network, I'm going to go ahead and tell it to go on VLAN 10. And I'm going to hit OK. Okay, now I see, well, you guys can't see, but the internet icon now has an exclamation mark. It took a little longer than I thought, but ipconfig now shows me as not having like it still has my old IP address, so it's not going to work anymore. If I ping Google, nothing. Like it's actually not even receiving an IP address. Okay, I realize what the problem is. So my Ethernet card is not getting an IP address, and I forgot one last thing I had to do, and that's actually back in the original switch. So I set up a trunk port for passing VLAN 10 to the extra interface on my router, but I forgot to set those trunk ports onto the ports that are communicating with the vSwitches. In other words, the cables going from the switch to each of the servers. So right now, even though the virtual switches are configured, they can't pass the traffic between those two switches with a VLAN tag of 10. So my switches are connected through, I believe, these 3 cables up here for one of the servers, and then they are configured through these 3 down here. So by adding these trunking tags to the VLAN 10 on the ports going to the other servers, aka the other switches, they will now be able to pass traffic, and I should be able to get an IP address on this machine. And there we go. Now we see a network prompt. Do you want to allow your PC to be discoverable? Yeah, go for it. So now when I do ipconfig, the IP address I'm assigned to this computer is .10.50. That's the first one in our DHCP reserve. So right now, I deleted the rules I had made while I was testing things. So for my other rules, I have a reference point of how each of my VLANs is working. VLAN 10 has no rules by default, which means it's going to have some issues. So if I was to ping 192.168.10.1, that would be the gateway. It can't see it. If it was to ping .1.1, it can't see it. So it can't even see the router. It can't communicate with it. If I was to ping 8.8.8.8, it can't go out to the internet either. So what we're going to do is make 2 rules first in our interface here for VLAN 10, because the firewall is prohibiting anything from communicating. So in other words, VM1 is saying, send this ping out, goes to the switch, and with that last step, this switch can now communicate that with this switch, but then this switch sends it to pfsense, but the firewall on it says, nope. So we can't go anywhere from there, and then it just kind of dies there. So the first thing I'm going to add is a pass rule for IPv4 UDP so that we can get DNS working. DNS is IPv4 UDP, and here for destination, we're going to select DNS. That's port 53, and we're going to say DNS. And I'm actually going to rename it with Traffic Shaper. It's something extra I do. So any internet-based traffic, I have my traffic shaping limiters that are using fqcodl configured, so I have to create an extra advanced rule, otherwise it can affect performance on my network. LAN and WAN. If you're not using traffic shaping, you don't have to worry about that. And then I'm going to add another rule, and this one's just going to be a default allow everything. So again, it's going to pass, and this is for the moment temporary. I'm going to say any protocol on both IPv4 and 6. that are coming from the VLAN 10 home network. And I'm just going to hit save and apply. When I'm pinging that same .8.8.8.8.8, it can actually go out to the internet now. So this computer can now actually make it to the modem and back. And if I ping the gateway, it can see that because we created a rule that just says allow everything. It can do whatever the hell it wants. And if I was to ping it on my physical computer that I'm at, that's 1.200, it can see that as well. So the next thing I'm going to do is I'm going to configure the same thing for the second computer. So I'm going to put the second computer on the VLAN 10 as well. So now I have the second computer on a different server on VLAN 10, and I can see it's 10.51. So now I have both computers on that VLAN. So VLAN 10, default VLAN 1. And right now they can talk to each other. And they can talk to the internet, they can talk to my computer on a different network. So I guess the next step in this whole router on a stick is maybe going into some detail as to how I can start isolating this. So if I was to, say, disable the rule for any traffic, I could just click right here to gray it out, apply changes. It'll still get DNS, but it's not going to be able to do anything. So if I was to ping from the first computer, let's say I wanted to ping my desktop computer, 192.168.1.200, it can no longer see me. It's a different network. There's no rule that's going to allow it to happen. But the second computer is on the same VLAN. So if I was to ping 192.168.10.51, it can see each other. So what's happening here is this computer and this computer being on the same VLAN, and these managed switches are all VLAN aware and trunking that. If this computer wants to ping this computer, the ping's going to go through the switch here to the switch here, and then it's just over the local network, and vice versa. So it has nothing to do with the pfSense. So if this pfSense router got unplugged, these two computers can see each other. If I create a rule that allows VLAN 10 to communicate with my desktop computer with like VLAN 1, it can't just go like that unless I configure the layer 3 routing on the switch, which I'm not doing. Instead, that's being done on the firewall. So in order for this computer to communicate with this computer now, it has to go through here, and it has to go into pfSense, and then that comes back out. That's the reason I have these extra cables. And if pfSense was to go down, this computer can no longer communicate with that computer because the switches will prevent that. They're isolated until the router says otherwise. So what this means now is I have some flexibility in terms of controlling what networks can see each other on the router on a single interface. So now, like some of the rules I did is, for example, let's say my VLAN 20, I have some extra rules, and I made rules for every single VLAN that I add, which will become exponentially worse the more you add. And realistically, you would probably be using floating rules, but I had trouble in the past with pfSense and floating rules in relation to traffic shaping, so I opted to having control on the interfaces themselves. What that means is if I create a rule that's not a global allow rule, because the LAN interface that my desktop is currently on has a default allow rule already. So when I created this allow all rule, they can communicate with each other. If I keep that off and I create a rule to pass traffic on this interface, we'll just say any traffic to the destination of the LAN network. We'll call it VLAN 10 to LAN. something interesting should happen. I'm going to shift the order just a little bit. I want the default at the bottom, even though it's disabled. Okay, so after hitting the actual save button, when I made my rules, this computer, my desktop, can no longer communicate to VLAN 10. So my regular LAN cannot communicate to VLAN 10. However, if I do the same in reverse, I can still ping the desktop computer on the LAN from the VLAN 10. So you can create these one-sided communications that might be useful for things like security systems, where you might want to access your NVR, but you don't want your NVR to be able to access anything. So we have that kind of power with that. And what I'm going to do is take the LAN and... no, I'm not. What I'm going to do is take all my other VLANs and create a rule that is going to be specific to that VLAN communicating to the new VLAN 10. And I'm doing that as just having rules for everything so that I can, if I need to change something, let's say VLAN 20 and VLAN 10 need to talk to each other, I just hop in here and I would enable a rule or something like that. Okay, so I added some rules and I disabled them to help mimic what my others have set up. So for all my existing VLANs, I went ahead and created a extra rule that goes to the destination of VLAN 10. So for like VLAN 20, I described them, I add descriptions so that I have an easier idea of what I'm looking at when I'm taking a glimpse. Now I also have this. This is a internet rule that I created. So like I have VLAN 30, and you can see here, I'm going to go ahead and click on copy. Actually, before I do that, let me show you what this is. So this is an alias. When you go into the firewall aliases, you can create a IP, port, URL, whatever. I have plenty of networks. I clicked on add and I created this RFC 1918 rule. So I'm just going to edit it to show you what it is. So I went on Wikipedia and I looked up what the local IP reserve ranges are. And this is what they look like when I added them as an alias. I even named them the same thing, so I had a reference point. Let's say I go into VLAN 20 and I'm going to click on copy. It's a pass rule that's going to go into the VLAN 10 in this case. All address families and protocols. This is the magic spot. So when you click on single host or alias and you start typing something, let's say R, you can see I have a couple different, this is my aliases that are showing up. I can click on RFC 1918, so that has all the rules for the local IPs, and then I hit invert match. So what this means is for all IPs that are not local area network IP ranges, we're going to either allow or disallow. And I'm just going to rename these appropriately so that everything is good. And in my case, this is an internet rule. So this is basically for internet traffic. It's going to go through my traffic shaper. And we can see right here, I'm going to move it down there, and I'm going to hit save and apply. And the order of things does matter. So I have my DNS thing at the top, and I have the default allow rule at the bottom, because it goes from top to bottom. So the first rule that matches is what goes. And you have to keep that in mind, otherwise sometimes things don't work the way you think it will. So right now, I have my DNS thing on, but I have everything else blocked. So my computer here, the virtual machine, if I was to ping, I don't know, google.com, it's going to get nothing. It's just going to time out. It has no internet. But if I wanted to give VLAN 10 internet, all I got to do is enable this rule and then hit apply. And now I could ping google.com. And I have this DNS rule because if I was to disable this, then I might... Okay, so it still pings Google, but let's say I wanted to ping amazon.com. If I was to try and ping something that's not already cached on the operating system, I can't ping amazon.com because it can't resolve it. Port 53 for DNS traffic is not going through. Yet if I was to ping, let's say, let's pick a different IP that we didn't use yet, like Cloudflare. I can ping an IP address, but I cannot ping a URL. So only by turning on the DNS rule, and I just keep that on for everything since I'm resolving things locally anyways, can I now access, say, amazon.com. There we go. It just took a little moment. So it now has access to my DNS server. So I can give it internet with this. If I needed to, if I wanted this VLAN to communicate with everything by default, I can do that and just enable it right here. It's just that simple. If I needed to communicate with another VLAN, I just enable a rule to do that. And if I'm working with the LAN, or well, any of these really, if I make a rule, for example, for VLAN 10 to communicate with VLAN 20, I need to make sure that I enable rules for them to go both ways if I need them to go both ways, which most likely would be the case under normal circumstances. So now what I'm going to do is I'm going to go ahead and take VLAN 10 to VLAN 20 and enable it. Then I'm going to go into VLAN 20 and enable the exact same rule, vice versa. So VLAN 20 communicating to VLAN 10. And by doing so, I should now be able to ping. There you go. So the benefit is by using the router on a stick, I'm able to manage all inter VLAN traffic between each other through just my firewall, instead of having to go into an edge switch or another switch and creating layer 3 routing rules, which I have yet to mess with. The edge switch I have does have layer 3 routing, but it just makes more sense for convenience to be able to do it on the pfSense, and the hardware I'm using is pretty overpowered to begin with. So the only risk is when these cables are routing lots of traffic. So one cable is LAN, another cable is 20, 30, and 40 VLANs, and then the one we just added is VLAN 10, right? So the idea here is if I have a computer on VLAN 10, and this one is on VLAN 20 right now, and this one is just on the LAN. If my virtual machine here needs to communicate, it has to connect to the desktop, it has to go into pfSense. It's coming up through this cable. And pfSense then goes to the firewall, and it's going to push it out that connection back into the switch, which is going to send it to my desktop, and vice versa. So if we're doing like a benchmark, it's not a case of where this virtual machine has to come in through this cable, go in, and come back out the same cable to get to another computer that's on that network, where we can see potential bottlenecking issues and things like that. So that's why I'm thinking in terms of multiple interfaces and separating home networks into individual interfaces that are separate. But that's basically the rough idea. It's a bit of a clusterfuck as far as my approach to this, and I'm sure it's going to be useful to nobody unless you just want to hear me rambling about stuff. But I figure I'll probably make like a second VLAN. If I want to take my normal infrastructure, let's say I'm applying everything I have and moving it into a home where I'm going to be managing other people, I may want to put those other people into VLANs separate from my own. And I may add interfaces to help compensate for bandwidth needs as necessary. So I might have like a VLAN 10 and a VLAN 11. And it might be like, everybody else is fine sharing with each other so they can be on VLAN 11 while I'm on VLAN 10. I got my privacy, everything's locked away and isolated, and everybody else can still communicate with each other, even if the router was down. Eventually, I will take my desktop computers. I have 2 computers I use. One is my main workstation / gaming rig, and my other one is primarily communication and streaming. And I'll try and put them into VLAN 10 so that I can test out what the performance is like, having my computers go through that extra step of routing. Now, I believe if they are communicating, let's pretend these were my 2 computers that I'm sitting at, that if I'm just sending traffic out to the internet, they would go through their dedicated link and straight out to the internet. If they have to communicate with each other, they're just going to go through the switch and directly over the LAN without the router communicate with each other. This is going to be a big deal for me because I use a software KVM switch input director, and I have to manually configure those IP addresses. So if I go into a different subnet, I have to reconfigure both computers so that I can actually move my mouse to the other computer as well as my keyboard. And the purpose of this will be to just test, like, if I'm gaming and if I am streaming, will this have a detrimental effect? Because it opens up a new layer of security options, especially if I'm trying to protect myself from things on my network that are outside of my control, such as roommates or other devices. But will there be a performance problem, whether it's added latency or something along those lines? And there is another side benefit to this too. When 2 machines are communicating and it's being done through the router, it can go through my intrusion detection system. So if I'm like doing something communicating between these 2 computers and it goes through my router, it's going to go through Suricata. If my desktop computer is infected with something and it has to go through the router's defense systems, such as Suricata, before it can communicate to this computer, the intrusion detection system will spot that signature and destroy access, and it'll probably block the desktop's IP, the local IP, temporarily. And then it's like, to the administrator, it's like, wait, my computer's not working, what's going on? And then you go and investigate and you see that its IP is blocked in Suricata. And then you say, why? And then you go and look at the logs and you see, oh, because of this and this. So it's got a lot of added benefits. What applies to me more realistically is that extra layer of security in any way going to interfere with the latency of playing video games and doing live streaming? So over time, I'll be able to find out. At the moment, I'm just setting up the VLAN, and that's really about it. I'm not putting my desktops onto it yet. I'm just getting things set up and just kind of experimenting with things as ideas continue brewing. I have no idea if any of that's going to ever be useful to anybody, but if you like hearing me ramble about stuff, well, I hope you got it, because that's all I got for now.